Assalamualaikum. Today I'm gonna show you the dimension friction force. In part A, we are gonna use the dimension online to find static force and the sum of force. Let's get it started. The first step is choose a box with mass 50 kg and set the friction to non-zero value. After that, drop the person forward to box to apply force of 50 Newton. We can observe that when they apply for 50 Newton, the friction force also 50 Newton. The sum of the force is 0 because it is in static or motion, that is minimum force. Next step, increase the apply force to 150 Newton. You can see that when apply force increase, the friction force is lower and the sum force is 56 Newton. We can see that the friction force is lower than apply force because the object in motion. Next, start over and put the second box. Slowly apply the force to 500 Newton. When the box is still moving, give the apply force to 0 Newton. And reduce the friction to none. We can observe that the box moves slowly because there is still some apply force left. After that, increase the friction to low. We can observe that the box is not moving when the no force is applied and when the friction is high.
For the next simulation of this lab, coefficient of static friction, firstly, click the following link, copy this link, and then open Google Chrome, paste on this Google, then search. After that will appear the simulation website. Click force, then choose inclined plane with friction to mass and a pulley. Following the instruction, we must adjust the angle to 0 degree. Mass of M2 10 kg. Show numerical value must click for easier to us do observation. For wooden surface coefficient of friction, we must adjust 0.25. Okay, then set mass of M1 10 kg. So for the next step, slowly reduce mass of M1 until M2 toward barely M1. So we must get the minimum kilogram that towards barely M1. Okay, we get 2.6 kilogram for the answer. Record this observation, then put to the lab report. Okay, after that, adjust the angle to 30 degree. Same mass of M2 10 kg, and then put higher 10 kg, and then slowly reduce mass of M1 until M2 toward barely M1. Okay, so just reduce until get the answer. Okay, we get 7.2 kg, that minimum kilogram, M2 towards barely M1 box. Okay, for the next step, following instruction on the lab, For the coefficient of friction, dry concrete on rubber, the coefficient we must change to 1.0 and then set back the angle to 0 degree, mass of M2 10 kg, mass of M1 10 kg. So we run what's happened. Okay, nothing happened. So when nothing happened, we must reduce mass of M2 from 10 kg to 8 kg. Okay, click run. Okay, slowly reduce mass of M1 until M2 box toward barely M1 box. Okay. Okay, we get the answer 8.2 kg. Record this observation and then fill the lab report. For the next instruction on the lab, adjust the angle to 30 degree. Set mass of M2 10 kg, 10 kg mass of M1, click right. So nothing happened. We must reduce mass of M2 to 8 kg. Okay, click right. Same thing happened. So we must reduce to 6 kg. So M1 have movement. So we must slowly reduce mass of M1 until M2 to early M1 box. Okay. Click run. Okay. For the minimum value that we get 8.3 kg that M2 towards barely M1. So record this observation at the lab. Okay, thank you. That's all from me. Assalamualaikum warahmatullahi wabarakatuh.